A few years ago, I bought some dice made of 99.9% silver. They have brought me some good luck, actually. I took these to my first major backgammon tournament in New York, and I won first place in the beginner division. But it's been a number of years, and the dice have tarnished to this really dull black color. So I'm going to clean these silver dice with a battery. So I'm going to make a solution of baking soda in water to make it more conductive. Okay, so this is a carbon electrode. So I'm going to connect the carbon electrode to the positive terminal of the battery. Positive. And the reason I want to go through the carbon electrode is that I don't want to introduce any other metals into solution, which would plate out onto the silver and contaminate it. Now let's wait for the solution to settle down, because I want you guys to be able to see the reaction in real time, because this happens very quickly. Let's take a last look at the tarnish. This is very ugly. Sometimes the tarnish can turn out very well, like a rainbow kind of color. In that case, I would keep it. Okay, negative terminal. Let's double check, because if the wrong terminal was connected, it will really tarnish the coin. Negative. And you gotta make sure the coin is not touching the carbon electrode. Alright, now watch carefully, because this happens very quickly. I'm always surprised at this process. Let's get the tarnish face showing. Let's see, this side is the most tarnished. Yeah, my carbon electrode is falling apart because I've also used it to make bleach in some of my other videos, so they've been used quite a bit. Alright, ready? 3, 2, 1, go. Now, I'm not time-lapsing this. This is really happening as quickly as you see in the video. So you can see a lot of bubbles forming on both the silver and the carbon. So at the carbon side of things, hydroxide ions are migrating to the positively charged carbon electrode and becoming oxygen gas. And electrons are moving into the silver. So some of the silver oxide is being reduced to silver, and then the oxide is combining with the water to make hydroxide. But also, as a side reaction, some of the positive hydrogen ions that are in water are combining with the electrons at the negative terminal and making a lot of hydrogen gas. That's why you see bubbling coming out of the silver. So you want the carbon to face the side of the tarnish, because that's where the most electrons are going to be flowing, because the solution obviously has much more resistance than the silver. So you want the path of least resistance to go through the tarnish. Let's give it another 30 seconds or so. It turns out you can also use this process to artificially tarnish silver. You need a solution of sulfides, though, because silver sulfide is what the colorful tarnish is made of, right? Using this process with the polarity reverse would make silver oxides and silver hydroxides, which have a very dull color by comparison. Alright, let's take the silver out to take a quick peek at it. The solution is very black because the carbon electrode is kind of old. It's covered with the carbon. Let's go rinse it off a little bit. So already you can see that it's starting to eat through the tarnish, so maybe another minute or so. And we want this side to face the carbon electrode. Now, it turns out a common hearing aid battery back in the day was of silver oxide. I don't think it's so popular anymore because it required a small amount of mercury to hold the silver in place. And I think mercury has been banned in batteries in recent times. The way it worked is it was made of an electrode containing silver, and as you would use the battery, the silver would literally tarnish. And as you discharge the battery, as you discharge the battery, silver would tarnish. And as you recharge the battery, recharging the battery was basically what we're doing right now. You're restoring the silver back to its metal form, right? So with the right setup, you could literally turn this setup into a battery. All right. Makes you wonder what happened to all the silver being used in the batteries back then. I don't seem to recall people very diligently recycling their hearing aid batteries after they were done with, right? Now, I'm using a 6-volt battery, but a lot of that energy seems to be wasted in producing the hydrogen and oxygen gases, as you can see. Which means that only a fraction of the energy is turning the silver oxide back into silver. With the right voltage, you might be able to do this process a whole lot faster. I know I've seen a whole lot faster than this for sure. Let's take another look. Much better. Yeah, another 30 seconds or so, it should be good. Yeah, so depending on how tarnished your silver is, I've done this many times, and sometimes if the silver is really badly tarnished, you can sometimes smell rotten egg kind of odor coming out of it as you're doing this. And the reason for that is when silver tarnishes, it makes silver, some of it is silver sulfide, some of it is silver oxide, right? And when electrons go into silver sulfide, the sulfide dissolves. And when it does, it reacts with water to make hydrogen sulfide, and that's what gives it a rotten egg smell when you clean silver. Now, sometimes some people claim they can tell when let's say you're going to a thrift store and you're browsing silver items, some people can tell if they have genuine silver by the smell of it. I suspect it's because of the tarnish. The silver sulfide is reacting with oxygen in the air to probably make silver oxide and hydrogen sulfide. That's my guess, at least. I have seen very old silver items that smell of rotten eggs, even without the cleaning process. There we go. Let's go rinse it off. kind of covered with the graphite that degraded off of the electrode, but that should wash off. Thanks for watching.